Okay, and we're recording everybody, just so you're aware of that. Okay, welcome everybody. My name is Jonathan Roberts and I am Director of the Australian Cobotics Centre. What we've got today is a little bit of an information session on people that are interested in potentially applying to be a postdoc in the centre or a PhD student. So we've got a set of slides. We're going to break this into two parts. I will give a sort of more general introduction to the centre and what it is. And then we're going to dive down a little bit deeper into the individual programs, and we'll give you people online that have dialed in an opportunity to ask questions. And at the end of the session on the individual programs, we've got some breakout rooms, and you can throw yourself into a breakout room that aligns with the program you might be interested in. And then you can speak to the co-leaders of that program. So they're here online, so you can ask very specific questions. So if everybody's happy with that, I will get underway and give you a little bit of context. Okay, so just so you know where I am today, I'm actually at one of the partners of the centre, the ARM Hub, which is the Advanced Robotics for Manufacturing Hub. And you see that picture on the right, that is in this shed behind me. So the question people have been asking us is, what do we define a collaborative robot or cobotics? And you can see that picture on the left here of a Universal Robot 10, so a UR10 robot, which is working next to Matteo, who is a metal finisher who works at one of the companies actually in the next shed to this one, a company called UAP. And he is working alongside this collaborative robot. Now, most people on the call are probably familiar with that scale of robot being known, particularly by the people that make those robots. They brand them as collaborative robots or cobots, meaning that they're, in theory, safe to operate alongside people or very close to people. Of course, it depends what you put on the end of that robot to whether it's safe or not. But that's what most people are familiar with, a collaborative robot. Our kind of definition is a little bit broader than that, in that we are going to be treating all sorts of robots as collaborative robots. And some of the research of the centre will be how you actually do that and how you make larger robots like this one you see on the right here. This is an ABB robot with a much greater payload than the one on the left. It's got about a 200 kilo payload, and you can see the scale of the robot there. There are many situations where you want to use that scale of robot around people, and currently that is not done in industry. It's the safety work has not been done really yet. There are some examples in labs around the world, but it's not a common thing yet. So we're not just talking about little robots like you see on the left, we're also talking about big robots. So it's any robot that is working with people or around people, we are defining as a collaborative robot. So that's the first thing to understand. Okay, so some key information. So we have been awarded the centre over a 5-year period. We started that clock counting 2 weeks ago, I think it is now. And we have effectively got $15 million over that 5 years. So there's, as you can see on these slides here, $8 million of cash and $7 million of in-kind over the 5 years. The ARC has given us almost $5 million as part of that. Right, so that's our funding. So we're relatively well funded for a centre of this type, and we've gone to the maximum time of 5 years. We've also then got, if you look at that box on the right, we've got 19 chief investigators. And so all of the academics that are on the call here are chief investigators of the centre. 6 of those are at UTS, 9 at QT, and 4 at Swinburne. We've then got 7 partner investigators who are people that are associated with the companies we're working with, and I'll show you a list of those in a minute. And then we're going to be hiring 5 postdocs and 16 PhD students. We also have some engineering resource associated with the centre. So because obviously we're going to be building things and supporting some hardware and software. So we have resources in addition to that, which is embedded actually in a team at QUT. We've also taken a very holistic approach to collaborative robotics, and I'm sure you've all looked at the website and you will note that this is not a centre that is just simply focused on robotics in an engineering sense. Now, of course, there is engineering in this centre, but it's far broader than that, right? And as you will see when we go through the program, we've covered the whole spectrum, because our fundamental aim is to try and overcome these barriers for industry to take up collaborative robotics. So it's not all about the engineering. So you'll see that, and it will become fairly obvious as we go through. We've also got a diverse set of companies. So you can see here the companies and organisations that are part of this centre. I've already mentioned that we've got the universities, QUT, Swinburne and UTS. We also have an international university partner, which is the Technical University of Dortmund in Germany. And then you see on the left here our current industry partners. So we have Weld Australia. Now, Weld Australia is a sort of an industry association that businesses who do welding tend to join. And they help those individual companies with all sorts of welding matters. That may be training, it may be just advocacy, those sorts of things. So we will work with Weld Australia and identify companies that are their members that will work in the centre. We then have InfraBuild. They are a large company that produces kind of raw steel products before they go to a typical steel fabrication company. InfraBuild sort of make the things like the metal bars and rods and sheets and things like that. So they have a need for collaborative robotics. They have a lot of manual handling tasks at the moment that are tough on their workers' bodies. So they're looking for new ways of doing things, particularly to improve safety. Cook Medical, a large medical device company, they have one of their factories in Brisbane, where I am now actually. So QUT obviously is in Brisbane, Cook Medical is just down the road. They make a couple of products here in Brisbane. They make a thing called an aortic stent, which is something that goes, in your aorta if your aorta is about to collapse. This is kind of inserted via an artery, and it's actually a product that is very difficult to make. It's made of cloth, there's some wire in there, it's stitched, hand stitched, very delicate stuff, very difficult. And they also make needles for IVF treatment, so harvesting of eggs. So these are quite long needles, and again, there's an involved procedure to make those. So they're interested in how collaborative robots might help. We've then got B&R enclosures. If you're dialing in here from Australia, you may have one of their boxes at your house. So they make metal boxes that, for example, house your electricity meter. So you should go after this call, go and have a look at your electricity meter enclosure. It may well be a B&R enclosure. Of course, again, for similar reasons to InfraBuild, that a lot of their work is very heavy duty manual handling, and they're interested in how you improve those processes for their workers. We then have IR4. They're a company that works along another company called S Manufacturing, who's a steel fabricator, and IR4 have developed over many years some very cool software that helps particularly robotic metal fabrication take sort of a design from somebody that's designed a steel building, like a large shed, a bit like the one I'm in here, and then their software can automatically decompose the design and figure out how that's fabricated using robots. They're a Queensland-based company also. And then we have finally the ARM Hub, which is where I am today, the Advanced Robotics for Manufacturing Hub. and that is a not-for-profit company that's aim is to try and help industry overcome the barriers for adoption of technologies like robotics. So we have it's a nice diverse set of companies. We'll also likely be adding a few companies as we go along, which is typical in these centres. So you know it'll get even more diverse. So the objectives of the centre, and this is very high level, obviously. So the basic objectives here are to foster opportunities for PhD students and postdocs to pursue industrial training. And you'll see a little bit later, there's going to be opportunities for you to actually base yourselves in these businesses for some of your time with the centre. We want to enhance competitive research collaboration between universities and other non-higher education sector organisations. I don't know if you know, but Australia actually ranks quite poorly in these league tables of countries where industry and university collaborate on a regular basis. In Australia, for whatever reason, that's not that common compared to many other countries. So we want that to improve. Also, Australia doesn't rank very well in companies collaborating with each other, particularly in research. So that's one of the ideas of this centre, is to try and improve that situation. We want to strengthen and collaborate and the collaborative robotics capabilities of industry and research end users. Again, there's not that great a take up yet of these sorts of technologies in Australia. And finally, I guess the end game here is to drive growth, productivity and competitiveness by linking to key growth sectors, right? So fundamentally, we need Australia's manufacturing industry to grow and hopefully grow faster than everyone else's manufacturing industry, because otherwise we're effectively falling behind. So that's that. This is a list of our core values. We say we are epic, which is kind of cute. So we're excellent, we're people-centric, we're innovative, and we're collaborative. We want this centre to be, a world-leading research centre with transformational outcomes for industry. We will definitely be excellent. We're very passionate about being people-centric, about being positive, inclusive, supportive. We're going to build people for the workforce of the future. And just the very nature of the centre, as well as being people-centric within the centre, the centre is trying to develop those research outcomes that will help workers in these manufacturing industries. So it's all about improving people's lives at the end of the day. We're going to be innovative, forward-thinking. We're going to create solutions through interdisciplinary research and industry experience. And as I already said, you will see this very broad interdisciplinary research when we look at the programs in a minute. And we're going to be very collaborative and unified in a shared goal to transform Australian manufacturing. Now, because we're so broad, actually, and so diverse in our experiences, that's actually a bit of a challenge in a centre like this. So many centres like this are far more focused on particular types of research, but we're kind of the other way, deliberately so. We need a method to try and overcome that challenge. So Jared Donovan is now just going to very briefly talk about this thing called the Open Innovation Network. Jared.
Thanks, John. So one of the things we're doing in our centre to try and achieve these objectives that John talked about of fostering opportunities, enhancing collaborative research, strengthening collaborative robotics capabilities in industry, and driving the growth, productivity and competitiveness of industry is this Open Innovation Network. And the idea here really is to increase the impact of the research that all of the people in the centre are doing. So our industry partners are incredibly important to us, and so is the rest of industry and the wider research landscape. So what we'll be doing through the lifetime of the centre is, through those 5 years, we have a core team in the centre, which is myself, Glenda Caldwell, Matthias Gertler and Nico Adams. We'll work with all of you in the different programs to try and publicise your research, find opportunities for collaboration, and really sort of help to facilitate that. I think it's one of the most exciting parts of the centre, not just because I'm part of it, but because it really challenges that as researchers, we've got to do more to create connections for our research with industry and with each other. So we're really going to try and do our best with that.
Thanks so much, Jared. So, of course, we're trying to attract you to join our centre. So, you know, what do we offer? So we've already talked this a little bit, of course, multidisciplinary and world-leading researchers. You know, we really do have the best people, which is obviously one of the reasons that ARC awarded us the centre in the first place. You know, they've kind of recognised that we're good. We think we've got a very flexible and supportive working environment. All of our university organisations seem very good about being flexible, particularly in the current era where there's been, you know, we have to be a little bit more agile in how we work, whether we're at home or in the office or in industry. And I think we've become pretty good at that, right? And we actually stay well connected, even though we're distributed. And of course, you'll notice we're distributed in 3 states in this centre. Eventually, there'll be opportunities for travel and industry placements. Of course, in the first little while, that may be a challenge while COVID all works its way through the system. But then we have built into the centre quite a lot of opportunities for travel and industry placements. That really is a core part of the centre. You know, we have to be actually working with industry and with each other at the different universities as well. There's going to be a lot of collaborative working both within and across the programs and institutions. So just because you're working in one program doesn't mean you won't have a lot to do with other programs. Because again, as I've already said a few times now, we think that it's the combination of these disciplines working together which will actually help industry take up these kind of robots. There's going to be training and development program, and that will include mentoring, and there will be practical communications training as well. So, you know, training is at the heart of the centre. This is, it's, you know, actually formally known as an Industrial Transformation Training Centre. So we're going to take the training part very seriously indeed. And then there's going to be an opportunity to input into the strategy and operations of the centre, and you'll get an insight into end user interests. So there will be opportunities for the PhD students and the postdocs to come to various committee meetings, strategy meetings, and understand how centres like this are managed, and also understand how industry works at a management level too, and an operations level. So, you know, you won't just be parked off to the side with your head down. You will be very much invited to many of these opportunities, so you can see how all of this works and get some good experience. So I'll just quickly talk about postdocs and then quickly talk about the PhD students. So we're offering initially 3-year level B contracts, and then there's going to be an extension opportunity for an additional 2 years because we have a 5-year centre. You will of course have your own research project that's totally aligned to the program. So I should firstly say there'll be 1 postdoc per program. So there are 5 programs and there'll be 1 postdoc aligned to each program. So you'll have your own research project there, of course, as well as working with the PhD students and the chief investigators on the other projects within the program. And you'll see a list of those in a little while. You'll have opportunities to work with the industry partners and an opportunity to work actually in the industry partners, where you can get lots of great experience again. And you'll support the program leaders who are all on this call as well with program management, such as reporting, team culture, communications, etc. And again, this is all with a focus on learning about research management, right? So this is all part of the training as well. And then finally, you'll assist with identifying and scoping opportunities for collaborations and additional projects. So you will see in a little while the slides for each program, which has a list of projects. Other projects will come along as the centre goes along. So there are the PhD projects are fairly well defined, but there are other sorts of projects that the industry partners will bring us. They may be very small projects. They may just take a few weeks or months, but other things will crop up, and we have a remit to actually help out and undertake those as well. If you hear a loud noise here, this shed is actually next to the railway line, so you may hear some big trains go past. Okay, on to the PhD scholarship information. So we have 16 scholarships available across the 3 universities. You'll see the details in the subsequent slides. The scholarship is tax exempt and it's indexed annually. You can see the figures there, $34,013 per annum for a period of 3 years will be provided to the successful applicants. And built into that is 4 weeks paid leave. Right? So that's kind of standard. And then part of this centre for the PhD student is a placement at one or more of the industry partners for at least 12 months. And that's not necessarily a 12-month, continuous thing. It can be broken up. It will depend very much on the particular project, the partners, and the stage of the PhD. So that will just depend. But you will get this fantastic opportunity to work actually at the industry partners' place. And then there's going to be an option for a casual research assistant contract from year 2. And that is effectively an extra 8 days per annum paid. So that will be paid on top of the scholarship. And that is actually to be paid to produce communications for your project. So I already mentioned that there'll be training on communications, but we will also be paying the PhD students to, for example, to make a video about your work. That sort of thing. So, which will be very useful to you as you go through your PhD to be able to explain your results. Okay, so this is the point where I can pause very briefly, and if anyone has got any questions about these general points, please let us know now. And I'm sure you've all used Zoom before. Either raise your hand, and we'll see if we can spot hands going up. Let's have a look. Has anybody got any questions? Feel free to type them in the chat or raise your hand. Don't be shy. Something's coming into the chat. Okay, of the $8 million cash, how much comes from the ARC? So 5 million comes from the ARC. It's not quite 5 million. It's 409. I don't think we went to 4,999,000, but it's very close to 5 million. And then the rest comes from industry itself. Any other questions at this point? If there are not, it's okay. We will continue. Okay. Oh, yes. Okay. So the reason for the question, Australian government has been very reluctant to support manufacturing. The amount, yes. So previously, Australia has definitely had a decline in manufacturing. There is no doubt about it. It seems sentiment seems to have changed. And it may just have been a relative thing. It may be that government wasn't necessarily against manufacturing. It's just that our competitors were more for it than we appeared to be. So we kind of fell behind. There seems to be a change of heart, particularly with COVID and having more capability within Australia. So manufacturing at the moment is all governments of all types are very focused on improving the manufacturing situation in Australia. It seems like the logical thing to do. But having said that, so are every other country, right? So it's become very clear that everybody's doing this at the moment. So yes, it's nice to see that it's finally recognised. Okay, more questions here. Sounds like a phenomenal centre to work for. It will be, I'm sure. Would postdocs be able to continue teaching alongside the work at the centre at a moderate level? I suspect is the honest answer there, but not as a main core of the work. So I'm also very familiar with this. I mean, I've supervised many postdocs. Many postdocs would like to keep their hand in a little bit in teaching, because I am very aware that when you go for, if you go for an academic job later, it's important that you have teaching experience. So at some moderate level, yes, but not at a kind of massive level. It's definitely not, you know, we're not looking at 50% teaching, 50% research here, but we will try and give opportunities where we can. Anything else? Okay, so, okay, great, you understand. Oh yes, no, it's that is a hot topic, making sure everybody has opportunities to keep their teaching up. Anything else? Otherwise, maybe I will. Okay, because we've still got plenty to push through, so I will just stop questions there and we'll move on to the programs. Let's have a look here. Okay, program 1. I think Teresa was going to start.
Yes.
So over to you, Teresa.
Thanks, John. I'm Teresa Vidal-Caleja. I'm Associate Professor at UTS, and I'm co-leading Program 1 in Biomimic Cobots together with Professor Cho-Chi Chen. We are looking for Program 1, we are looking to recruit 1 postdoc based at UTS and 3 PhD students working in Project 1, 2, and 3 that we will talk in a minute about. This program aims to address the fundamental challenges enabling robots to work with humans in the conditions that Australian manufacturing industry demands today. And obviously we want to build the skills and capacity for the future workforce applying these new technologies. The program will develop innovative methods and techniques in perception, awareness, learning, adaptation, and manipulation through many techniques like multi-sensor data fusion, deep and machine learning, learning by demonstration, and digital twinning to allow robots to collaborate with and mimic humans, enabling to operate in reliable, adaptive, and comfortable material handling, welding, inspection, processing, polishing, many applications. The program seeks novel solutions to multiple research questions, right? How robots can gain skill or knowledge with no minimal task-specific programming, how robots can mimic humans through sensing and control programs to achieve finishing tasks, manufacturing tasks, and how robots can collaborate with augmented mobility executing complex tasks. Now I think Professor Cho-Chi Chen is going to talk about the specifics of each program, and then we'll move on.
Thanks, Teresa. Do you want me to talk about all 3 projects or just the second one? The second one?
All 3 projects.
All right, okay. Hi, everyone. As Teresa mentioned, I also co-lead this program 1. It's a very fascinating program. Everyone wants a robot to work for varying tasks, or even hoping robot can learn skills from one task and augment other tasks, and robot work with each other or with human beings. So there are 3 projects in this program, very fascinating. The first one is actually based in QUT, is a cobot contact tasks through multi-sensory deep learning, and requiring the robot to be situational awareness through contact sensors, particularly for a lot of contact tasks, and robot handling large pieces or doing finishing job, machining job. So it's a very challenging program to move the robot cobots to work in the constrained environment. I think this project is going to be supervised by Peter Koch at QUT. And the second project is about cobots learning digital twins. So it will be supervised by myself and Johan and my colleague Matt at Sumba University of Technology. We have been paying attention to challenges in cobots. We know that there's limitation in cobots to adapt to different working environments or to tasks with different conditions. So we are hoping that we develop some novel methods in a very novel way, using sensors and deep learning to actually digital training human beings. The robot digital training human beings, obviously the human can improve the performance by digital training robots. So that is really a broad picture for this learning digital trainings. The third project is about cobot manipulation with augmented ability. I think it's going to be supervised by Teresa's team at UTS. Again, very fascinating opportunities and to move the robots to a different sphere. The robots won't be just a fixed-based industrial robots. Looking at mobility and cobot systems. So that requires a different dynamic model perception as well as coordination and control. So overall, very challenging three tasks. I think they're very suited for very aspiring PhD candidates. So we welcome applications. Thank you.
Thank you. Okay, well, now we'll go on to program number 2.
It's me. Thank you, John. Hey, my name is Marcus Wittenbrook from QUT, and I co-lead this program with my colleague, Jared Donovan, also from QUT. So program 2 is called Human-Robot Interaction, and it's really sort of about understanding how to interact with robots, and specifically in this case, how to interact with collaborative robots in industrial settings. And to us, that's a pretty critical question, because when you think about cobotics, the level of interaction really sort of becomes much more complex. If humans work closely with robots, there's much more ways that we need to understand how we can best interact with robots in an efficient and safe manner. And one specific thing that we're interested in here is to have an approach that also considers design and the context of this interaction. So we're looking very much at the people, how the people work in these industrial settings, how they collaborate, and what the workflow is, and how the humans and robots work together in this context. So we have 3 projects, and I'll come back to the positions in a moment. So 1 postdoc, 3 PhDs. The first project, it's probably the most specific one. That's about robotic intention visualization. That's if a robot works with a human, how can the robot visualize in some way what it's planning to do? That could be route planning, it could be status, it could be sort of danger, it could be task related. And there are ways for the robot to show what it's doing through, say, projection, sound, light, and so on. So we need to figure out how we create this level of awareness. So that's also a PhD project at QUT that's led by myself. All the projects are with our lead industry partner, Cook Medical. The second project is Human Robotic Interaction Prototyping Toolkit, also led out of QUT by my colleague Jared. And that's really about sort of having a prototyping toolkit to allow us to not just sort of come up with the solution but really sort of go through a much more flexible prototyping process that allows us to look at what if we use different modalities, what if we had different settings, sort of really explore different ranges of how to build the robot before it goes into the industrial setting. So that could be using AR and VR, for instance, or other ways of prototyping. And lastly, we have a project on multimodal human-robot collaboration led by Mark Carmichael from UTS. And that's really specifically looking at all the different modalities that are suitable to a closely coupled HRC. So many modalities are known: sound, vibrotactile feedback, speech, etc. But sort of really looking at how these best combine in different settings is what we're aiming to do. So each of these projects has a PhD student, and we're aiming to attract a postdoc who has a background in human-robot interaction, human-computer interaction design, to bring that human-centered element. Thank you, John.
Thanks, Marcus. Okay, Matthias and Glenda.
Yes, I will present it. So my name is Matthias Güttler. I'm from UTS, and together with my QT colleague, Associate Professor Glenda Caldwell, I'm leading Program 3. And yeah, this program focuses, basically like the rest of the center, but here we have a specific focus on the seamless integration of cobots into an existing workplace. And by doing this, we more or less combine all the other programs in our program. So really bringing together the social side of cobots, the technical side of cobots, as well as the organizational side of cobots. And this is also reflected in our 3 projects. 2 of them are based at QT, 1 is based at UTS, and yeah, they are led by Glenda and myself, plus a couple of other CIs. All of them are also in collaboration with industry partners. At the moment, we have a small issue with the UTS partner, but we will have solved this issue soon. If you have more detailed questions, John would be the best person to talk to. But talking about the projects, so project 1 is called Human Factors in Collaborative Robotics. So you will see it directly links, for example, to program 5, but is probably a bit more technically focused here. So it addresses all the issues on the human knowledge, human interest and motivation around using a cobot. So support the use of a cobot, but also barriers to using a cobot. So we will look into, for example, user acceptance, trust in this new technology of a cobot, how this can be supported. It also addresses issues like the social work environment. So for example, what does it mean if instead of working with your mates, you suddenly work with a cobot? How does this affect your work and the acceptance of this machine? But it also looks into workforce readiness, worker safety, positive effects like the reduction of operator fatigue, and so on. The second project is quite interesting because it focuses on mapping the different domains of a cobot. So it aims to develop a methodology to map technology side to the human side, to the workplace side, to the product side of a cobot. Basically around the question, what you as a company, what do you need to do when you want to set up a cobot? How do you pick the right cobot? How do you maybe design the right cobot for your problem? But also how do you need to adjust everything else so it really makes the best use of your cobot? For example, how do you need to adjust the product? How do you need to, for example, change from bolts to clips, or maybe change the shape of the surface so the cobot can better grip it, etc., etc. So it's really how can we identify the links between the dimensions, how can we map them, and how can we turn this into a guideline so companies or researchers later on can really make use of it when they want to employ or install a new cobot. The third project focuses on augmented and virtual reality. And here the question is, so it also links to program 2, how can we simulate a cobot in a new environment? So reasons could be to identify the best cobot solution for existing environment, or to explore how the workplace need to be adjusted to make best use of a cobot, but also in terms of building trust and acceptance of a cobot, so workers could already explore upfront how the cobot would sit in a workplace and work with them. Yeah, that's the brief overview of the program.
Thanks, Matthias. Okay, program 4, Nico and Mickey.
Yeah, thanks, John. I'll kick it off. So program 4 is titled Quality Assurance and Compliance. This is, I'm Mickey Clement, I'm at UTS. And I co-lead this with Nico Adams, who's at Swinburne. And we've got a couple of partners, and Cook Medical is also quite interested in the data quality and traceability aspect of this. So he'll be heavily involved in the latter projects. So the overall idea of this program is there's a keen desire to have manufacturing that produces high quality products. And when you add cobots into the mix, we have both an opportunity and a challenge with that. So the opportunity is we can integrate quality assurance, compliance, and traceability into the process itself rather than having that as a separate step. The challenge is that we need a data framework and information model, as well as some algorithms and techniques for processing the data that we collect from the cobotic activity to make that happen. And so the structure of this program is we've divided that software infrastructure and how we structure the data collection to make it usable by humans for those regulatory and quality activities into different areas. And so we've got 4 projects here. And I'll turn it over to Nico to explain the first 2, and then I'll do the second 2, as the first 2 are based at Swinburne and the last 2 are based at UTS.
Thanks, Mickey. Yeah, so as Mickey was saying, the foundational project, if you will, for this program is the first project. And the first project, the goal of the first project is to try and develop a framework that allows us to comprehensively represent both robotic tasks as well as human tasks, as well as the intersection of robotics and human tasks as they work together in a data infrastructure. To do that, we need to do a number of things. We need to develop mechanisms to elicit knowledge from workers. It's easy to, based on a process analysis, to understand and program a robot alone. But as robots are collaborating with workers quite often have tacit knowledge when they carry out tasks. So we need to develop frameworks for eliciting that tacit knowledge and then encoding that tacit knowledge into formal structures that can be represented back to a robot and from which robotic automation can be developed. And so therefore the second component then of the project is to develop a data model to hold all of this information across the whole robotic process automation lifecycle. To date, a lot of scientific work is being done around the end of the process lifecycle, i.e. the programming and the deployment, but that initial assessment of process automatability and tacit knowledge is underdeveloped. And then finally also to develop some analytics tools and processes to judge the likely automatability of some of that tacit knowledge and potential tasks that we're eliciting. In the second project, then, what we're trying to do, and there's some alignment with other programs, and then the second project, what we're trying to do is we're trying to use digital twins, in essence, for the virtual commissioning and validation of robotic process automation. So once we've looked at processes we want to automate, once we've come to a view as to their and an assessment of their automatability in project 1, we'll then want to take that through into actually developing cobot prototypes, also in the context of the environment and the larger factory environment, to again assess the system, to judge automatability, to prototype it virtually, only then to build it subsequently in hardware. That's what the first 2 projects are about, and project 3 and 4 follow on from that. Back over to you, Vicky.
Thanks, Nico. Yeah, so in project 3, we're then applying these models to try and interpret what's happening in the process in a way that is usable for humans for regulatory or quality control processes. Right? So this is taking the type of information that the robotic system captures from the previous 2, and then interpreting it into a way that can be used for documentation that's usable by humans, not necessarily just usable by the robots themselves. That's project 3. And then project 4, there's some measurement theory things that we need to sort out when it comes to monitoring processes as you do them, to make sure that the quality metrics that you get are valid. And so there's a validation process that needs to happen there, as well as some statistical learning that we can do to improve the process. And so this project 4 is really in the details of using the data and developing models to convert that into something that is quality or traceability related.
Okay, thank you both. Oh, sorry.
Yeah, sorry. I was just going to say, you may notice that all of these are closely aligned. They run into each other. And so the idea for this program is that the PhD students will work as a cohort quite closely together. Perhaps that is a key feature of this program, that the PhD students will be working incredibly close together as a group.
Thanks, Mickey. Thanks, Nico. Okay, program 5, this is the last program. So I think I saw Penny and Greg were online. Not sure about that.
Yes, we are, and I'm going to be presenting.
Okay.
So I'm Penny Williams from QUT, and I'm from the School of Management, along with Professor Paula McDonald, who is the Associate Dean of Research in the School of Management in the Faculty of Business and Law at QUT, and Professor Greg Hearn, who is from the School of Design at QUT. So we have 4 projects in this program, and the emphasis of our program, I suppose, is on the human robot workforce. So we're particularly looking at how the implementation of cobots change the workplace, the experience of work, employment opportunities, and the skills required in the future of advanced manufacturing. So we have 4 projects, 3 of which have PhD scholarships associated with them, the first 3, and then the 4th project, which will be led by the postdoc. So very briefly, the first project looks at the future workforce. So with, I suppose, 2 kind of sub-research questions within this. One, how does the implementation of robots into the workplace change the skills that are required in advanced manufacturing? And the second one looks at how does it change security of jobs? So how do workers feel about their income security, their job security, labour market security, and does that change with the implementation of robots into the workplace? There is actually surprisingly very little research that looks at the impact on the workforce, and so we've got this really fantastic, unique opportunity to do that as part of this centre. The second project, called Manufacturing Jobs of the Future, rather than looking so much at the impact on the worker, looks at the impact on the job. So it takes more of a job design perspective, looking at does it change, does it improve the safety of jobs? Does it change the capabilities that are required in those jobs? Does it fundamentally change the job itself? The third project, which is called Managing for Workplace Readiness, looks at the implementation from more of an organisational change perspective. So we know that when you implement robots into a workplace, it's going to create change. So what we want to know here is, what are the leadership implications for this, and what are the change management implications? So this project looks at things like how do we manage the workplace? What are the barriers to that change? What are the skills required for leaders and managers moving forward? And then the 4th project kind of cuts across the other 3 and looks at how the implementation of cobots can improve the diversity and longevity of the manufacturing workforce. So we know our industry partners are really looking at using robots to improve safety in the workplace, to allow a more diverse type of workforce, for example, more women to enter advanced manufacturing, to enable people who might have been injured at work to stay at work longer. So this project really looks at how that actually happens. And while there are no lead industry partners listed on this slide, we do have some. So Weld is one of our key industry partners, and so is B&R Enclosures. We're actually going to be in discussion with all of the industry partners and looking for some new ones, because many of our projects cut across organisations as well as go deep into specific organisations. So I guess the key with what we're doing is looking at solutions that can be applied at an industry level, at an organisation level, and also at the worker level. So that's it.
Thanks so much, Penny.